Okay, good morning to everyone. And we've been listening to Thelonious Monk, a little bit, what? Ruby, my dear, for a little bit longer than I intended because I was answering a question regarding Course Compass and my math lab, and Larita was explaining to me some of the problems that are going on. So what I'm doing is opening up 3.1, and I had 3.2 open. Isaac could come in and ask a question. And so I'd opened up 3.2 a little bit later than I intended. But certainly in terms of 3.1, what I'm going to do here quickly on 3.1, because I just went ahead and I'm going to try to talk and do this simultaneously. But a reminder, today is the day before the exam. Okay? And so most of what I want to do today is review. Answering questions, trying to see if we can end up feeling comfortable with what needs to be done. And what I'm going to do is run 3.1 through tomorrow. Okay, so I just set up 3.1 so it can be done up through prior to the test. So that's been done. And I already have 3.2 going up through that same time tomorrow prior to the test. And you said 2.6 still needed some time? Okay, I'll open up 2.6 and try to get these set up so we can have those available for people. And that I'm doing through 2.5 also. So that's been done. I checked to see how many of you had spent any time on the practice test, and I don't have anything indicated. I did ask Sarah yesterday, what's the approach to doing this as far as what you needed to do, and I'll explain that in a moment. I just want to make sure I have these dates correct. So I have 2.6 through 3.2 and through practice test 1, all up through tomorrow prior to class. Now, the question was, when you go to the, what I guess is your page you get when you log in, there is a little tab or a little oval that says Take Test. That's what you have to click on. So take a test, and then that'll give you the practice test for chapters 1 and 2 that I've set up for 30 questions for 90 minutes. Now, you have to be careful. If you hit submit instead of next, you're out. And so if that happens, and you couldn't come back in, is that correct, Isaac? Yeah. So what had to happen, Isaac came in here, at least there may be a way of getting out, but at the moment I ended up having to open it up on an individual basis so he'd only done one problem and hit submit instead of next, and his grade wasn't so good. Yes, James. Yeah, do the whole thing and submit. Don't submit after each problem because it'll kick you out. And then I've got to make a decision of whether to bring you back in or not. So be cautious, okay?
Little box does pop up that tells you if you want to close.
Okay, so it gives you a warning. You didn't see the warning. Okay, is it, now I had set it up, okay, question here. I had set it up so it's supposed to give you a time, a running time left. It does? Yeah, so you have a clock running at the top. I wanted you to be aware of how much time you had left. Now that also increases your stress, so that's the downside. Yeah, you can, again, you can skip, but as you go through, does it show you the problem, or you have to click on each problem to see it? It shows you the next problem. And if you don't want to do that one, go to another one, and okay. So you can just sort of leapfrog your way through the problems till you see something you like. Yes, easy ones first, harder ones last. Good strategy, I agree. Is there anything else that we can help there as far as how to pursue that? Okay, now the way this works, this becomes part of your homework grade, not a test grade. So I'm taking your homework grade and I'm taking these 3 practice test grades and bringing those in to get your overall homework grade. And as I look at your homework grades, they're very strong because you get to do it as many times as you want. So we're looking at hundreds and 90s and 80s. And then I take that and balance it out with your practice tests that you've done to give a more realistic idea of what you can do without having an opportunity to redo each problem as many times as you want. Now, the question that was asked, I can't remember for sure who asked this question a few moments ago, but if you do well on the test, does that indicate, this is the practice test, does that indicate that you would do well on the paper test I give? A couple things I want to talk about there. First, the way I selected the problems from the book for that test is exactly the way I'm going to be selecting them for the test I'm going to write. And I haven't written it yet. I was going to wait until we finished our discussion today, and then I'll be writing the test because I didn't want to bias my comments towards the test one way or the other. So I'll be choosing the same kinds of problems. I'll be choosing fewer problems because we only have an hour. And so it'll be more like 20, 25 max, depending on how easy some of them are and how hard some of them are. One of the things I was hoping, and it hasn't happened, I was hoping I'd have some sense of how quickly you were able to go through the 30 problems, because that would have given me a very good idea of whether I need to be restrictive in how many problems I place in the test, or if I could give you 30 problems. Not knowing that feedback at this point, I'm, in a sense, going to have to write the test on a hope and a prayer and think that I've got it timed appropriately. So that's not your fault, and it was just a hope on my part that maybe I would have that feedback. But there's another point here that you have to be cautious about. If I want documentation on the test you do in class, and I want you to show me how you're doing your work, and you haven't been really doing that as you work in the computer, you just throw your answer up there and get it, then the time frame is going to be different because I'm not going to give you full credit for an answer without documentation. So that's a wrinkle that's a little bit hard to, I think, look at what's demanded and say, how does that compare to what you do in the computer? Now, if you're doing what I've asked, as you enter your answers into the computer and you've shown the documentation in your notebook that I've asked you to have, you should find the time constraints about the same. But if you've not been showing that documentation and you get through the problems in a hurry, but you don't know how to document your work, I'll only give partial credit for a problem without the documentation. So if there's 5 points in a problem and I take 2 off because you didn't document it, there's 20 problems, there's 40 points off your grade and you're at a D. I want documentation when appropriate, just as we did in Math 10. So if it's a problem written down, intermediate step and answer. Problem, intermediate step and answer as a minimum. My hope is that if you go through and really do well in that 30-question test, that that'll translate into a very good job on paper. But I also know that it's in a different format. Doing something on the computer and doing it in a test in class doesn't translate the same way. And I've heard critiques given by students that say, boy, I could do everything in the computer, walked into the test, did it by hand on paper, and didn't do well, comparatively speaking. That's what you have to be careful of. So as you prepare for this test, you need to be looking at problems in your text. Write down the problem, show your work, get your answer, and check it against the answer in the back of the book. Now, if you can do that in 20 problems in 1 hour, then you're ready. But if you're going to operate on the basis, I've been working on the computer every day, an hour a day, and then take the test, it's not going to translate across. So just a caution. I call it pushing your pencil through practice problems prior to taking the test. You have roughly, maximum, 3 minutes per problem. It's about the time to boil a soft boiled egg. You have to do that same time per problem on the average. And what James said, I think, is very critical. It's a lot easier on a handwritten test to look at everything than to sit there and pushing next and next and next. You just look at the problems, you go through, do them in order. But you look at a problem, and you ask yourself, do I know what I'm doing there? If so, do it. Get it done. Get all the easy ones done. Build up a level of confidence. Build up what, in essence, if you can do the problems quickly, and it only takes you 1.5 2 minutes per problem, you've got 10 problems done, and you've only used 20 minutes, you've got suddenly 40 minutes there, which means doubled your time on the remaining 10 problems. And that's good. One thing that's not asked for in the computer, and one thing I will have as part of the test in some way, the properties of the real number system. The 10 we've done, with the exception of Emily's property, which is the multiplication inverse. Okay, so that's where you have to say, for example, A plus B equals B plus A community property. Yeah, well, you shouldn't have to memorize them because you did memorize them. You have to remember them. Now, if you didn't memorize them before, then yes, take time to do so now or write off 10 points. Okay?
So it's going to be 10 points on the test?
It'll be 10. 10 properties, 10 points. I'm just not sure how I'm going to do it. Okay? So I've got to think how I want to do that as far as the test. But you will be responsible for the 10 properties. Now, there were some questions. And Larita has shared some of them with me in terms of 3.1 and 3.2 with the vocabulary. Isaac gave me one that I have up on the board that I wanted to discuss. It was related to 3.1. So let's start with Isaac's problem. And Jonathan, if you'd be kind enough to go to the board with that. The problem was this, the expression. And I'm assuming this came out of a problem that came from the computer. Yes. So it's not necessarily a problem each of you've done, but it's of the type you should be able to do. I have a fraction, b plus 6 over 6 minus b. Now the question, what value for b makes this fraction undefined? Now, I mentioned to you yesterday, I think it was, I remember making the statement that we have some things we can't do. They are taboo. We cannot divide by 0. But there are two different problems involved with that dividing by 0. Now the first one, to have 3 over 0, we just say is undefined. If you think of your answer, it must multiply times 0 to give 3. There is nothing defined in the numbers that you can multiply by 0 and get 3. So that's an undefined. Indeterminate is where you have 0 over 0. Because I could take a million different numbers and make that true. 5 times 0 is 0. 100 times 0 is 0. 7 times 0 is 0. Anything I put in there times 0 will give 0. It's not possible to determine the correct answer. So we say indeterminate. Here, simply undefined. So I'm asking in this problem, is there something that will make that denominator 0? Yes. If b is 6, this denominator becomes 0. That's what I've shown here. And if b is 6, I have 12 over 0. Hence, undefined. Now, we are going to have expressions like this that we're going to change to equations. And we have said that b can be any integer at this point. Now, I've also indicated that when we talk about the properties, we say we have 3 letters, A, B, and C. And remember, this looks like a E, means belongs to, a member of. You're in the club. And the club is the reals, the real number system. Okay? Now I'm saying A and B can be any number. In this problem, I'm restricting the values for B. I'm saying B cannot equal 6. if b equals 6, you've got a problem. So we've restricted the variable. Now when I say a, b, and c can be any real number, I'm going to use a new word for you. It's called the domain. It's the set of numbers that we have. The domain for most of what we do in algebra is the set of reals. We have restricted temporarily the domain to integers. This is a further restriction. So we say b can be an integer as long as it's not what? 6. So we could say b belongs to big I, that's the integers, and b not equal to 6. That's my restriction. And if I do that, this fraction then can have anything you want substituted in for b other than 6. You can take any integer you want for b as long as it's not 6. That's going to become very important in algebra because we don't want a denominator that's equal to 0. Things blow up. And in terms of a graph, we've talked about, and interesting, just for a comment, I watched yesterday's Math 70 lecture on television that we do at 4 o'clock. Yes, had to stop and think what hour it was. It was the same lecture basically we did in 20 yesterday. Exactly the same content. Because we were talking about polynomials. And we were talking about binomials, trinomials, monomials, degree, single variable, double variable. That was all in the discussion of Math 70, and it was exactly what we'd done in 20. And the point in pre-algebra is you cover about 50% of the algebra class. So that when you take the 70, you have a running start. If you get in grades that are going like roller coasters and you're a big rig, and they will say crank it up as you're going down so that when you come back up, you don't gear down and lose your speed. Well, this is sort of get you ready so when you go into algebra, you can crank it up at the first part, and then as you hit the hard part, you can maintain what you're supposed to. So that's what this question's about. There is hardly a thing we do that you could put in the category just chasing rabbits and don't worry about it. It's to have success at the next step, you've got to pay your dues. You've got to put the time in. You've got to know how to do it. And it can't be a case where you try it once, try it twice, try it 3 times, and maybe the 4th time you get it, you now have to go back and try it 3 more times, so every time you get it in those 3 tries. Any other question in this problem? Okay, let me go to another question. And again, all I'm trying to do today is respond to questions and comments that have been asked. Okay? And before I forget, now that I've done all that work here before this computer squawks at me, I'm just changing something there. I'm going to slide over. So come with me, Jonathan. And let's talk about polynomials. Not very creative. 3, 2, and 1. What do we name it and why? There are 3 terms, correct? Each of these is called a term. If you add something together, each part is a term. Now this is algebraic as an expression because it has letters in it. Variables. What makes it an equation? If I have an equal sign. So I could say equals 0, for example. Okay. This is an expression. Now there are 3 terms, and I made a comparison yesterday to what we had done in naming large numbers when we went back to the Roman system and said if you had a single bar, that was 1 extra group of 3 zeros. 2 bars was 2 extra groups. 3 bars was 3 extra groups. And so when we had 3 bars, we called it a trillion. Here's your try. 3. 3 terms, try, and we say nomial. That's the way we name it. If there are 2 terms, like billion, binomial. Okay. Now, it doesn't work when we have 4 terms. We don't say, I have trouble saying this, quadromial. We just say a polynomial. So we talk about a trinomial, a binomial, and a monomial. And you simply have to decide what you have when you see an expression. Question, Michael.
Can a mononomial be a polynomial?
Each one of these is technically a polynomial. So that polynomial is all-inclusive. Anything from a monomial, binomial, trinomial, and beyond are all polynomials. We talk about the degree of a term. Now this is just, you read what's said and you memorize it. And try 30 problems until you have it. The degree, if you see a single variable, the degree for that term is the exponent on the variable. That's a second degree term. Now here you say, well, I don't see an exponent. Well, that's the unseen one that's there. That's a first degree term. Exponent. The degree is the exponent on the variable. This technically is x to the 0. Hence, degree is 0. So again, I look at a term, I look at the exponent on a variable. If there's only one variable, the exponent is the degree of the term. Third degree, second degree, I'm sorry. I was unfortunately thinking of 3 terms. Second degree, first degree, 0 degree, 3 terms. What is the degree of your polynomial? The highest degreed term. So that was a 2, a 1, and a 0. So the highest exponent was a 2. Therefore, second degree trinomial. Now I used this one as a contrast. Very simple monomial. But it had 2 variables. And what you aren't seeing is the 1 here and the 1 here for the exponents. If you have more than one variable in the term, add the exponents on the variables. 1 and 1 is 2. That's a second degree monomial in 2 variables. A verbal description. Folks, you just have to memorize it and do it. There's no choice here. How many variables? 2. Second degree monomial in 2 variables. That is simply language, and you just have to go through and memorize it. Sandra.
So, if you had it, like, would we ever have to translate it the opposite way, like you give a verbal notation when we have to translate?
Okay, good question. If on the test I say, and what Sandra's asking, do I ever work backwards? Oh, it's a good suggestion. I like the idea. Give me a monomial in 2 variables, degree 3. 2 variables, monomial, degree 3. Sandra, tell me a number, an answer to that.
So I could put x, y, but instead of, yeah, and then 1 behind the x and then y at 2.
You got it. That's a good answer. That was a monomial, 2 variables, degree 3.
Wait, say that again. That's a what?
How many terms? How many terms right there?
2?
It's a single term.
Oh, because, okay.
You just multiplied 2 variables together. If I had this, now that's 2 terms, but that is a binomial, second degree, in 2 variables. Which one? This one? This one up here? That's a monomial, 1 term. You multiply garbage together, you have a term. Third degree, you add the exponents on the variables. You have a 1 and a 2. Add them. 3. No. Coming back to here. This was a second degree term. This was a first degree term because it was a 1. This is a 0 degree term. Now, I need to come back to Pareto because we're spending too much time on this one section that may have 1 or 2 problems, and we've spent nearly 20 minutes doing what we did yesterday, and you have 6 sections in Chapter 1, 6 sections in Chapter 2, 2 sections in Chapter 3. That's 14 sections, and we're spending time on 1 out of 14 and spending half our time, maybe, on that one section. Now, what I'm understanding as you ask your questions, you're having trouble making these classifications. Now, they're pretty straightforward as classifications. If that's bothering you at the moment, let it go. Hear me one more time. If this is hanging you up, let it go, because if you can handle the other 12 sections, you can do extremely well on the test. Don't chew up your time on the latest new section. Yes, it's important, but if it's not going in 24 hours for you, let it go and make sure you can do everything else very well. This will work out. It's language, but you have to spend time on it. And I don't mean the time that many of you are currently spending. 45 minutes to an hour per day, you're at 50% where I want you. Just let that sit there for a moment. 2 hours a day, minimum. 2 to 3 hours above that studying for the test. If you're sliding with less than that and you're surviving, you're living on borrowed time because you will hit the wall. Okay, question. You had your hand up. Okay, I thought you had your hand up. James. Okay, for which section? 2.5. Okay, letting go of 3.1 into 2.5. What is the question, James? It's a what? A long problem. Okay, a word problem or just a order of operations? So you're telling me I don't have room for this here? Probably not. Okay, go for it then. Braces. Otherwise, I should brace myself for something. Braces. Absolute value. Negative 15. Open parentheses. Negative 6. Close parentheses. Like that? Wait. Oh, that closed this off. Like that. Done. Thanks. So I have a divide by here. Is it okay if I just come down here? 2. Bracket. Open bracket. Negative 11. 81. Close bracket. To the third. All right. Nice problem. Okay. Now, I got suckered into something 2 days ago on this one, doing it as 2 separate parts and forgetting to do order of operations. Let's not get trapped this time, so be careful. Watch what I do so I don't end up with that. I'm going to look up here first. So what am I going to do inside? Go inside here for the absolute value, correct? Now, without showing all the steps, I have here what product when I get done? A 90, correct? And a minus of 46. 15 times 6 is 90, and they're both negative. I'm multiplying. Positive 90 minus 46, and so you got a 44. So the absolute value of 44 was 44 plus 4, and so this first part became a 48. Do we agree? And where did you? You didn't get the 48? Ah, okay. Now, but let's carry it through. Then the next part. I'm going to take this 81, take the square root, that's a 9. The minus 11 plus 9 is a negative 2. So that is divided by a 2 times negative 2 to the third. So let me write this. The next thing I'm supposed to do is what? Exponent next. So that's minus 8. Now this says go back and do what in order? Multiplication and divisions in order you see them left to right. So 48 divided by 2, 24, which I'm going to multiply by negative 8. So that's going to be a negative
192.
8 times 4 is 32. And again, what I'm hearing you say is you just neglected the plus 4. Because I had a positive, and this. This is where it sometimes helps to do that maybe. And if you put a dot between there, maybe that helps even more to see that you have a division and a multiplication and so on. We okay now? Now the danger here. James just got caught with it. I got caught with another one the other day. And when you're working in a hurry, dropping that 4 off just because and there's no explanation. You look it back and say, I shouldn't have done it, but I did. Okay, what I will try to do is I go through and grade it. Let's say everything else had been done correctly, but the 4 just disappeared. Then I would go some partial credit. On the computer, it just says, no. And you get to try again until you finally get it. But it's these little steps. Again, I'm going to come back to Pareto. Now, Pareto says 20% of something explains 80% of something else. So production, 20% of the things you're doing account for 80% of the problems you have. This is the hardest problem in Chapter 2. Now, you could spend 3 hours doing nothing but these problems. And then remember the quiz. 5 questions, all easier than that. And I had a lot of papers at 50%. So if you do all your study on that problem and you let the easy stuff go, you're going to make silly little mistakes that'll cost you a grade or 2. Statement made to me, unfortunately, didn't occur until I was nearly in graduate school. And I wish somebody had told me first semester out. Make very sure you can do what you think you can do. You feel really good about section 2.1, 2.2, 2.3, 2.4. This bothers you. You go back and you spend a half hour on problems from 2.1, 2.2, 2.3, and 2.4 so you can do those without even thinking. You practice them. Don't just look at them. Unless you do them, you don't own them. Got it? So don't get overconfident on these little pieces that you say, hey, I've got that. Because all I have to do is give you this. And you blew it. You just blew it. But you just blew this one. What are you thinking of? No, you're thinking of parentheses. Yes. This is a 4. I agree, because it is the inverse of the additive inverse, but this is the inverse of the absolute value. This one comes out minus 4. This one comes out 4. Even when you know it, it's easy to get confused.
Wait, why does it, I thought absolute value is just the distance, so why is it minus 4?
The inside was the absolute value, which was 4. Now, what is the inverse of that? Negative 4. This, as a parentheses, you have two ways of thinking of it. The inverse of the inverse of 4, which is 4. Or you can think of it as minus 1 times minus 4, which is 4. My point, I think, is well made. This is so much easier than that. But here, 5 points in that problem, and you get the wrong sign, 5 points off your grade. Another easy problem. Okay, these are, I'll slide this one in here. Minus 2 to the 4th. What's your answer?
16.
Positive 16? But if I change it to this, what's the answer?
Negative 32.
Okay, it's a negative 32. Now those are easy problems. And you're going to see some easy problems on the test. They're the bread and butter. Get your 60, 70% on the bread and butter problems. Those are the easy ones that you're supposed to be able to go through that James is talking about. Hit them fast, get them, check your work, but they're also the place where you will second guess yourself silly. Other questions? Larita.
Can you do 6x squared minus 4x minus 1?
Okay, we'll do that. But before I do that, Jonathan, camera 1 where I am now, please. 3 up camera 2. Start it going to the sideboard so I can go over there quickly. So as soon as I see you move, okay, that was a switch, and we got the camera going, okay? Larita's giving me a problem. And she's, I suspect, reflecting a question that's been asked. So will you give me the value again as Jonathan cuts to the board? 6x squared minus 4 times x minus 1. Evaluate when what? Negative 8. Okay? So you substitute. Be careful. This must be done in that first substitution. It is the negative 8 to the second, the quantity to the second. Then a negative 4 and parentheses, a negative 8 with a minus 1. Now, if you don't substitute correctly, it's not going to work. If you do substitute correctly, there's a chance it'll work. No guarantees. The danger here, not seeing this as 64. You see the 8 and the 2 and you think 16. So this is 64 times 6. What do we get? Positive 64 times 6. 384 I'm hearing? Is there any support for that? We got a support, okay? Now, what about this? What are your choices? You can say positive 32 immediately, or you can treat that as plus a negative 4 times a negative 8. Your choice, but it does just come out 32. Now this minus 1 here, you can treat as plus a negative 1, or you can just write it the way I did. Addition and subtractions in order given. So if you add these in, you're going to have 416 minus the 1 for 415. We got it? Robert first.
I have that same problem on the computer, but mine
Okay, so you had a 7 here, otherwise the same?
Yeah, the middle was a 6, and then the last one was a 5.
Well, it was quite a bit different. So what you had, 7x squared minus 5x plus 6?
Plus 1, or minus 1.
You had this minus 1? Like that, Robert?
No, the middle one is 6. So, and then the last one is minus 5.
Jeez. That it now?
Yeah.
Okay, so it's a lot like the first one. What was your x?
The x was negative 5.
So x is negative 5. But you're right. You're going to do the same thing. Different answer.
I did that for mine. I believe I got 100, and he told me it was 101.
Okay, 7 times minus 5 squared minus 6 times minus 5 minus 5. And so that's going to be 7 times 25. And this is going to be plus 30 minus 5. And so this is going to be 175 plus 30. Curl. 175 plus 30 minus 5. Have I got the substitution now? Slide over just a little bit, please, Jonathan. We in agreement? Okay, so this is going to be 205 I get 200. If you've given me the problem as it was written and the substitution as given, and I do this work, I'm sorry. There is no way that we're going to come up with. Okay, we are still having occasional problems where the computer has not been programmed appropriately. So you leave the problem and go on to another problem and write down what you have. And I do have the ability to go back and give you correct solution for that. And you come in like Isaac did. We go on the computer. I make the change and so on. Here's a problem. Don't chew up your time battling the fact that the computer's not agreeing. If you've checked your work, and particularly if you with somebody else are looking at it and you're pretty darn sure that the problem is with the computer, not with your work, go to the next problem. We're trying to take care of many of these as possible, but this is the first time I think this edition has been set up with my math lab, and there are a lot of little glitches. And if Larita's around and she can check it and say, yeah, let's go on. Don't battle the computer. Other questions? A yup. Okay, let's go with the yup. Does that make you a yuppie? Yeah. Okay, yup. Go ahead, James. Okay, 1922, does it give you square inches? Height is, how many inches? 31 inches. Find base. Formula? Okay, area is. Now you gave me the right side of the formula. So the formula is the area equals. Formulas are equations. Area equals base times height, BH. And sometimes the base required a little bit of addition, right? As you did in the quiz, where I think we had a 6 and a 3 for a 9. Okay, so you have two choices here. What the text is asking you to do is substitute and solve for the letter that's left. So if you just played this game without the units for the moment, you'd have 1922 equals B times 31. Now, we talked about this yesterday, and Larita asked the question about rewriting that as 31 times B. That would be more common. But you want B by itself, so you simply do this. And now you have to divide. And that takes a little bit of doing, briefly, but that would be your answer. Now, what's your alternative if you don't want to do it this way? You could come back and say, let's solve this for B. So I have A is equal to BH. Just divide both sides by B and rewrite it H on the left side, because if A is equal to B, slide over, Jonathan. If A is equal to B, B is equal to A. So that tells me that H is equal to A over B. Okay? Which is exactly what I did here. Didn't I want H, or I wanted B? Not. That right? Solve the base. So I didn't divide by the right thing. Divide by H. So if I divide by H, then B is equal to A over H, which is what I had. Well, you're going to get the answer, yes, at some value. 62 seems reasonable to me because I need a 2 at the end and I need something 3 into 19, 6. So 62 seems reasonable to me for that answer. And so I would typically say B is equal to 62. Does that answer the question? One thing you didn't do that I might encourage you to do. Just because. Parallelogram. And then 31, and B down here. I would expect a diagram whenever we are doing formulas for areas, volumes, perimeters, etc. Appropriate diagram. Other questions? Sandra?
So whenever you go to the problem like that, you want us to write out the whole formula?
Your choice as to whether you do this or this. This is pushing you towards algebra. I like this. I encourage this. But if your comfort zone is here, stay with your comfort zone and get it correct on the test.
But it's the same thing, right?
You get the same answer. Okay? Other questions? Pyramid with the stacking of the... Yeah, it was weird. I don't see going there on the test. No weird pyramids. However, cubes are good. We did that in Math 10. So let's zoom in up here a little bit more so I can... Cubism. I feel like I'm in an art class suddenly. Okay, a cube and I say it's 5 inches by 5 inches by 5 inches. I expect you to be able to tell me that the volume is 5 inches cubed. Because what is your formula for the volume of a cube? The volume of a cube is s to the 3rd power, correct? Base times height times width, s times s times s, 5 times 5 times 5. I don't think cubes are bad, but I like this problem still. Remember this one? On a quiz? Roughly speaking? Oh, 6 circle.
I hope you're not giving this.
This is what we did in the quiz. It's from last semester. Well, I said, it was on a quiz this semester, yes. We did not do well on it. This was 3, this was 4, this was 5, this is 4, this is 4. Let's say this is 6. Inches are the quotation marks. Singles is feet. So what did you do to solve a problem like this? Just a reminder. Where I got all these little dotted lines, you took scissors and cut it up. So this is a rectangle. Doesn't look very good as a rectangle, so I'll call this 6 here to make it look more like the square it looks like. This is 4 by 6 up here then. So you have a square at 6 by 6. You have a rectangle at 4 by 6. You have a right triangle, which don't use the 5 for the area. It's the base times the height over 2. And then you have this half circle with a radius of 2. I don't see doing that again because you've been there before. But that, you're responsible for. Michael. We're back to negative signs and open parentheses. Okay. Do I need this space or up here? Up there. Okay. Negative sign parentheses?
Yeah,
Open parentheses.
negative sign.
Negative sign again.
Open parentheses, negative sign, open parentheses.
Yeah, those are me.
Oh, I like this. Negative.
Open parentheses, 42. Then close parentheses.
1, 2, 3, 4. Close, 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 close. Okay, it's like saying the inverse of the inverse of the inverse of the inverse of the inverse kind of argument.
Would you
Count the negatives.
No, wait. Would you go that way or that way?
Doesn't matter.
Okay.
How many negatives do you have? 4 inverses. What's the best way of looking at this? Watch. It is. 4 negatives multiplied together? Positive 42. Does that answer? That's a diabolical one. I wouldn't go quite that far. I might have 3. Okay?
You can do 7.
Ready for 7? Any other questions? We're down to about a minute or so. Dion.
I have a problem from 3-1.
Okay, you want to fire it away?
Negative 8z,
8z, negative 8z,
negative 4,
negative 4.
Z,
What this is evaluate this expression, the expression negative 8z minus 4, when z is 6. So negative 8, substitute for z, a 6. You have negative 4. This becomes negative 48 minus 4, negative 52, done. So if you think of this as plus negative 4, yes. Okay, Ernie, I'm down to the last few seconds. We're listening to Thelonious Monk. So what is your choice? Blue Monk. Like a blue funk. Anyway, Blue Monk with Thelonious Monk. And with that, remember, tomorrow is a test for you. And for those of you who are watching, we'll repeat today's lecture tomorrow. So